In the previous video, we set up the visual structure of our application using pages, panes, and layouts. Now comes the exciting part. Let's add all the actual cute quick controls that will make our home climate system interactive. In this section, we will introduce most of the cute quick controls we'll add to our project. When introducing a new control, I will outline some of its most useful properties and how they work. Note that every control will have the same basic properties of padding, inset, background, and content item. I won't mention these again for brevity, but be aware that they will be used. We have already been introduced to application window, page, and pane. We will add a checkbox for enabling and disabling a zone, a switch for toggling the display units between Celsius and Fahrenheit, a dial for changing the zone's temperature, and finally, a slider for controlling the fan speed, and a label to provide information to the user, such as the application's name and current temperature. The first addition will be the humble label. A note about the label component. Although part of the Qt Quick Controls module, it inherits from Qt Quick Text. Label inherits padding and palette properties from text, but adds its own background component and inset properties. Additionally, label is one of the few Qt Quick Controls that does not have a locale property. Let's assign the label to the page's header property. Label shows us a good example of the difference between the width and height properties and the implicit width and implicit height properties. The latter is the natural dimensions of the control if it were sized to perfectly accommodate the entire text according to the font and text properties. This means the implicit size will change as the text and/or font changes. The width and height are those dimensions we impose on the control. This may be bigger or smaller than the implicit size and may cause the text to be clipped, realigned, elided, or even scaled if the properties from Qt Quick Text are used to control this behavior. Set the text of the label to climate control using the QSTR function. As with other controls such as application window that also have a header, a footer, and possibly a menu bar, the control assigned to one of these properties has its width set automatically to match the parent control. Its height, however, will be whatever we set it to. And seeing as we are not setting a height, it will be the implicit height of the label rendering the text climate control with the font properties we set previously in the application window in main.qml. Let's set the font color to white so we can see the label text better on a dark background and increase the font's pixel size to 48 as this will be the main header for the climate controls. We also need to add some padding as Page does not have default padding for the header or footer. Now let's remove the red background and test the app. Note that we now see a white background instead of the brushed metal we had previously set. This is because the background color inherits the application's style and theme, so we need to set the background to null. Setting the background to null not only means we do not have a background, but that the default one provided by Page is never actually created. This is a nice optimization by the QML engine and happens when an ID is not set. After building and running, we should see the brushed metal background. Next, let's fix up the green and blue rectangles in zone controls. Open zone controls and remove the two blue rectangles in the column layouts. We will still have a rectangle for the pane background, but let's make it more subtle. Set the color to black and opacity to 0.5. Lastly, let's give each zone a name. Add a string property called zone name to zone controls and switch back to climate controls to fill in the property with a name of your choice. For ease, I will use zone 1 and zone 2. You may prefer to use room or floor names, just make it your own. This property will be used in a short while as we fill out the visual details in the zone controls. Our app should now look like this. Some of the controls properties will bind to the zone controls pane, so we should give it an ID, root, ensuring we can qualify all of our property bindings when we add them. It is good practice to qualify all your property bindings with the target ID to avoid any unforeseen problems when you want to move or restructure your QML code, as it ensures bindings are absolute and not relative to some other unexpected scope. For the left column of the zone controls, let's place a checkbox in a new row layout with the usual 10 spacing. In the row layout, we'll add a new checkbox and give it an ID Zone-Enabled checkbox. We will find this is useful in other bindings later. A checkbox is a type of button containing a checkmark symbol and some text to describe what is being checked. It can be toggled on, checked, or off, unchecked. Checkboxes are typically used to select one or more options from a larger set of options, but can also be used independently as we are doing. Checkbox inherits from abstract button, where it gets its checkable and checked Boolean properties. The checkable property defaults to true, whereas the checked property defaults to false. Checkbox also has a tri-state property, which defaults to false. A third state, partially checked, can be used when set to true. Checkbox adds the check state property to manage this. It is an enumeration listing the three specific states: unchecked, checked, or partially checked. Being an item, checkbox can also be disabled or enabled using its enabled property or that of one of its parent items. To enable the zone by default, we can set check to true. As a side note, this is the first of many cute quick controls whose properties can be changed by touch, keyboard, or mouse, or by modifying the code. It is good practice to handle property changes only when a control changes a back-end object during user interactions. For example, use the onClicked signal handler to read the value of checked state that has changed due to the user interaction. The clicked signal is not emitted if checked state is modified from the back-end code. This pattern will crop up repeatedly with other controls, and it is good to understand which kind of user interaction or programmatic interaction will cause onward changes to keep your UI running nice and smooth by avoiding unnecessary property change processing. Let's get back to creating our checkbox. Add the text to the checkbox using the zone name property we added earlier, using the simple placeholder syntax as shown. This will display the word enable and your chosen name for each zone instance. Let's take a look at our progress by building and running the app. Don't worry about the color of the text just yet. We will be using the palette property to bring some consistent color changes across all our controls later. Notice that the checkbox is vertically centered. This is the default layout position of row layout and column layout, and we will implicitly take advantage of this for most of our controls here. The next control we will add to zone controls is a switch. Add a new switch component just below the checkbox. Switch is an option button that can be toggled on, checked, or off, unchecked, and is typically used to select between two states like checkbox. It also has the checkable property, which it inherits from abstract button. Switch can also be dragged or clicked to toggle between its checked and unchecked states, and it provides a nice little animation as it changes between states. Unlike checkbox, switch doesn't have a tri-state option, meaning it is strictly a binary selection. It also adds two read-only properties, position and visual position, with decimal point values between 0 and 1, that relate to the indicator's position during its animation between its checked and unchecked states. The visual position has the same value as position unless layout mirroring is used, in which case its values are reversed. Give the switch an ID. Note that you can't use switch as an ID because it is a reserved keyword in JavaScript. We will also give the switch some text to show its purpose, in our case, which temperature units to use. You can find the degree symbol using your operating system's keyboard shortcut, or you can type \U00B0 inside the string as demonstrated. This is the UTF-16 character code for the degree symbol. While we are here, let's fix the color of the checkbox and the switch using the palette property of the pane. The palette property contains several color role properties that are inherited by items and are available to ensure that custom controls maintain a consistent look and feel. Let's set the palette property of the pane using the group property syntax and set the window text color role to white. Now, we can build and run to see the checkbox and switch in action. Next, we will look at one of the most prominent controls of our application, the dial. Dial provides us with a natural way to interact with our application, mimicking control knobs you may find on physical devices such as an oven or home theater system. Many controls, such as buttons, switches, sliders, and dials, mimic real-world control systems to provide a familiar and intuitive experience. A dial allows the user to select a value within a specified range, with the value property set to 0 by default. You can interact with the dial in multiple ways, by clicking around the dial to set the value, by dragging with the input device, or with a keyboard. There are several ways to modify the behavior of the dial, some of which we will look at later. Before we add a dial to our app, let's add a new row layout with the usual spacing. This way, we can later add icons to the dial to convey its purpose. To ensure our dial reacts to the checkbox we created earlier, we bind this row layout's enabled property to the zone-enabled checkbox's checked property. This means that when the user enables or disables the zone, the dial will respond accordingly. Add a dial component to the row layout. For simplicity, we won't specify a size for the dial, so it will just be the dial's implicit size. We are yet to identify what this dial will be used for. Typically, a dial on a climate control system would control the temperature, so let's do that. We need to specify the from and to property values to create a range in which our dial operates. The selected value will be held within the value property when we move the dial between its minimum and maximum position. We will start by setting the operating temperature range of our dial using Celsius, and we can use the switch we added earlier to convert this to Fahrenheit. Let's set from and to 0 and 40 respectively. To watch the value change, we can use the onValueChanged signal handler to log the current value to the console whenever the value property changes. Let's see it in action. Notice it is quite difficult to see the dial against our background. Dial uses the dark color palette role for its elements. So, we can set the dark palette role to a lighter color in our pane's palette property. Using the palette and its property role names may seem a little confusing at first. Play around with the palette and its color roles, and you will quickly become familiar with them. To learn more, look at the color group and palette QML types in the Qt documentation. We will customize the colors of our app even more later on. Let's check the dial is now displayed in white. We can see that when we interact with the dial, the value change is smooth and granular. Climate control systems usually allow users to modify temperature in whole degree or half-degree increments. To implement this with our dial, we can use the step size and snap mode properties. Step size determines how much the dial's value is increased and decreased when interacted with via the keyboard. If we want step size to be respected for touch and mouse interaction, we must also set snap mode. The snap mode works with the step size to allow the handle to snap to certain points along the dial. The snap mode value is an enumeration of 3 possible options: dial.noSnap, which is the default, dial snap always, which snaps while the handle is dragged, and dial snap on release, which snaps only after the handle is released. As an exercise, play around with the different snap modes and step size values to get a handle on how they affect the dial's behavior. Learning what properties a control has, and most importantly, playing around with them is the best way to learn. For example, the live property is a Boolean that determines whether the dial provides live updates for the value property while the handle is dragged, or position, which is a normalized value between 0 and 1 across the dial's range. Take a look at the dial's documentation page and experiment with the properties to customize the app so far, spending some time to make it your own. Our climate control application would not be complete without a large element showing the user the desired temperature. We could simply bind the dial's value to the label's text. However, we want the user to be able to change the displayed temperature between Celsius and Fahrenheit. To begin, we will add 2 properties to our pane, starting with an integer for Celsius and then another for Fahrenheit. We will bind the Fahrenheit property to an expression that converts the Celsius property. Before we add a new component to display the temperature, we need to give our previously created dial an ID and set a default temperature. Then, we can bind the Celsius property to the dial's value. Now we can add a label component to show the temperature. We'll add this in the empty column layout we made earlier, so items in this column layout will be shown on the right-hand side of the screen. We will use an extra light font weight and a large font pixel size to create a large, clean-looking element. We will get the label to fill the width of the column layout and align the text to the right-hand side. We can now bind the text property of our label to a JavaScript expression containing a conditional operator based on the unit switch's checked property and display the corresponding temperature in Celsius or Fahrenheit with the appended symbol for each. Let's have a look at the application in action. Currently, we can enable and disable each zone, control the temperature, and switch between the desired temperature units. You may have noticed that the larger font size of our temperature label has artifacts on the edges. This is because the pixel size we have chosen has started to hit the quality limit of the default render type text.cute rendering. For Qt versions below 6.7, we set the render type quality property to text high render type quality to help improve the appearance of the large font sizes at the expense of using more memory. With Qt 6.7 onwards, you can change the render type property to text curve rendering, which has better results for larger font sizes. It can also be considered in instances where reducing graphics memory consumption is a priority. We now have a nice clean look to our temperature display, and our application is coming to life. Let's add one final control, a slider to change fan speed for each zone. Sliders allow users to adjust a value by manipulating a draggable handle along a defined track. You may see them widely used for adjusting volume, zoom level, or manipulating photo filters in your favorite social media app. The slider type in Qt Quick Controls is very similar to dial and switch in a number of ways. Similarly to the dial, the slider also contains the live property and allows you to control the step size and snapping. You can also set the slider's orientation, which defaults to Qt horizontal. As you gain more familiarity with Qt Quick Controls, you'll see that there is a lot of consistency between their common behaviors, making it very easy to learn how to use new ones without too much guesswork. Our slider will control the fan speed in each zone. Let's add a slider to the same column layout as our temperature label, but place it inside a new row layout first, so we can add icons to each end later. Give the slider an ID and set the from and to values to 0 and 100 respectively. We will set layout.fillWidth to true so it fills the row layout and subsequently the column layout on the right of the zone. As we do not want the user to control the slider when the zone is disabled, we can set the enabled property of the column layout to prevent any accidental user interaction. Let's test the slider by disabling the zone and verifying that it does not respond accordingly. Customize the slider properties and zone layout to your liking and get to grips with the additional properties we haven't covered. We've built a complete interactive interface using Qt Quick Controls. We've explored labels, checkboxes, switches, dials, and sliders, and seen how their properties work together through bindings. In the final video, we'll add the finishing touches, icons and dynamic colors that change based on temperature to make our application truly come to life.